Everybody. I'm Mike Olson. Let's get this kicked off. For some reason, I'm not hearing Humphrey or anybody's audio. We tested this. Everything was golden, but you know how things go. So I'm being told that you can hear me. And as of right now, you should be able to see me too. So let's hope everything keeps going right. I'll be watching the chat here. Let's just make sure. Yep. All right, we're going. Humphrey says we're all golden. So don't know what's going on with that. But anyway, welcome to today. Thank you for taking the time out of your day to join us today for another webinar on the FXM-HP. So a lot to talk about there. So those of you who are here today are those who are probably the die-hard technical tab that really want to dive deep again. And so I appreciate that. Spent a lot of time figuring all this stuff out. There's a lot to it. It's not hard. There's just so many opportunities and things that you can do with this great system. So let's get into it. So today is about custom data. So with custom data, you are really in control. It gives you the ability to greatly, in an enhanced way, control dry contact relays and other things, user alarms, so on and so forth, with the system. And you get to really decide how things work and how it's all going to tie together. So let's dig into it. I mean, it's almost a superpower, I'd say, Humphrey. It's pretty cool. All right, let's dig in. So custom data, you can really what you're going to do with it is you're going to write a formula, and that formula is supported with variables. And those variables, they're monitoring things within the system. So for instance, you can watch the AC input and output, battery counters, timers, and much, much more, just basically monitoring what's happening with the system with each of those variables. And those are shown behind me here. All right, so we currently have 4 variables set up on this screenshot. And we're actually going to go, this is actually a sample of what one of the things we're going to do today. But so we've got the 4 variables, and then we've got the equation here, and they work hand in hand. All right, so we're going to get into that a little bit, but let me show you what you need to do first. Okay, so the setup is like this. I think it helps to have an overview. So the first thing we're going to do is we're going to go add custom data. It's a button we're going to click. Next thing we're going to do is we're going to set our variables, and there's 2 kinds, numeric and state. Then we're going to write the equation based on those variables using operators. And then the last thing is, what do you want to do with that? So now you've got this equation, it's doing what you want it to do, it's working. What is the output going to be? Probably most of the time you're going to control a dry contact relay, but you could control other things, counters, timers, alarms, and more. So again, add the custom data, set your variables, write the equation, and then output. So variables and equations, so those are the things we got to get into. So let's talk about variables first. All right, so we got to have these to make this work. Right, because the formula is going to monitor these. So for example, what we're going to do here is we're going to go to add numeric variable or state variable. That's what we're going to add, and we're actually going to do this live here pretty quick. And so a type of variable is numeric. So think of it as a value. So if you want to monitor something that's got a value, say, for example, on this slide, AC input voltage, we can monitor that. We can say, hey, when it gets above a certain value, maybe 130 volts, whatever number you pick, do something because of that, right? So that would be a numeric because we're actually watching a value. And on this screenshot here, you can see that currently the field value would be 121.7 and whatever it was monitoring, and that would constantly update and compare that against the value that you've got set to see when it's going to do some action. All right, so that's numeric. A state variable is another kind, and this is the one that we're going to be using today, is a state variable. And so this one I've named it LBNL, low battery, no line, which is actually one we're going to use today. And what it's monitoring is the status of the low battery and no line. So when the batteries get to 40% or below, that would indicate a low battery status, and oftentimes we would drive a relay with that. But then also we're also making sure that the line is gone, so you're actually would be in some other mode than line. So we're looking for that, and this becomes then a true-false type statement. So, and then we're going to set this up, true if it's true, or you could do the inverse and say true if it's false. Okay, either way. All right. Then you can also add more statements or true if, like so. So there's other parameters that come in. So it's not always true false. It could be a mode of operation, which you're going to see when we look at the inverter part of it. So two variables in, you got to pick which way you're going to go. Am I looking at a number, a value that I want to keep track of and go either high or low of that, or am I looking at a mode of operation or a true false condition of something within the system? All right, so that's our two types of variables. So then we tie those together with operators. That's what builds our equation. And so there's quite a few operators. You've got some basic math ones: add, subtract, multiply, divide, less than, greater than. So these are all common ones you'd use. Logic statements, so the and. So if you're looking for more than one thing to be true or more than one thing to be false, or however you're lining it up, you would use the and statement, so the ampersand symbol, or is a vertical line. So you could be using or statements too. We're going to use both of those today. And then we've got the equal statement too. And then when we write these, be sure to use parentheses, and I'll show you this in the actual equations. You're going to want to frame up each section in a parentheses. All right. So what about writing the equation? Okay. So this is what it looks like when you've added a custom data, and we've named it here. We're going to do that for each of them. Here's the equation part of it. All right. So this one's already written. How you do it is you would click then this pencil, which always means edit. So you click that, and it's going to take you to this window. And here's when you actually write your equation. So when I first started playing this, I was like, yeah, but how do I write an equation? What are the rules, right? So if you're in a spreadsheet program, you would use equal first to trigger the fact that, hey, I'm writing a formula or something like that. Here, the equal is implied, all right? But what helps me when I think about these formulas is I think of them as an if-then type statement. We're not actually going to write if, and we're not going to write then, but it helps my brain to write the equation properly if I say if blah, 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 and then I know the output is I've got to do something else with the output. So I don't actually type in if or then, but it helps frame my mindset to know, okay, so for example, if morning rush equals false, and evening rush equals false, and inverter equals true, and low battery, no line equals true, then do something. So I've got all these sections, so let's frame them out for you, make it a little easier. So here's one variable I'm monitoring. Here's another variable I'm monitoring. So we've got 4 variables here that we're tracking. And with each of those, I've chosen to put an and statement, so the ampersand, between each of them. So all 4 of these must be what it says in order for me to then go do whatever it is I want this thing to do, right? So I'm going to have this driver relay. I'll show you how to do that. But I've got to have these 4 conditions met. Morning rush must be false. Evening rush must be false. The inverter must be on, and low battery, no line must be true in order for me to drive that relay. Okay, so that's how you break it down. It's helpful here, excuse me, to look down in the help section. All right, so I showed you the list of operands. They're right here too, so you can see what they are if you forget. Yeah, what are my choices for operators? Here they are. The definition's not there, but for the most part, they're pretty explanatory because you're probably going to use either, you know, math equations, or you're going to do equal and those kind of things. So anyway, remember to build with parentheses to keep your variables all set up and separate. Okay. All right. So. Okay, so then after you've done that and you've said okay and you've entered it, you want to check for this. You want to make sure that your custom data status says valid. Okay, what it's doing, it's going to error check the formula that you just wrote. It takes a couple seconds, and all of a sudden that'll pop up and it'll say valid, or it's going to give you an error, and then it's going to tell you where that error occurred, and actually it's going to count then the characters across in your formula and tell you where the error is. So for example, I'll show you this in the sample here, but when we go farther out, you'll see that I'm going to make an error here on purpose, and it's going to tell me exactly which character to check for. Okay, so it's going to check for right after the number it tells me, and it's even going to tell me what it's expecting at that time. Okay, all right, so always be checking for that. It says it's good, and you can see it came back then with results, numeric or Boolean. So numeric means it's going to come back with a 0 or 1, or Boolean would be true or false. Okay. All right. So what are we going to talk about today? So we're going to do two different custom data actions that we're going to set up. Okay. So the first one we're going to do is time of day and low battery, no line. So we're going to tie those two together. You just saw the formula. I'm going to show you how to bring all those variables in and how to make it work. So why would you want to use this one? So let's say you've got an intersection and it has high volume, and maybe it's got the opportunity, maybe it's at an exit ramp, at the top of an exit ramp. And if during rush hour you had an outage and you happen to be in flash, that could be bad because you could be backing traffic up onto the freeway, which can be an unsafe condition. So things you've got to decide as engineers as you lay out your signals. But if you wanted to, you could still have it go to flash at other low battery conditions. So let's say it's not rush hour and you've got an extended outage and it's been running backup for 4 hours and you've got more time to be in backup. So why not be in flash? Because that will get you more runtime in the street because you're about half power in flash than you are in fully automatic. So it gives you more indication time on the street, but also then would allow you to not be in flash during rush hour. So that's your call. You guys got to decide how you're going to set up your systems, but you can do that with this. So by setting up this custom data action, we can make this happen. So let's dig into it a little deeper now and figure out what it is we're going to write. What is it we're trying to accomplish? And I think it's easiest to do this with truth tables, to logically lay it out and say, okay, what are the things we're going to monitor? And when do I want these conditions to be true? I think this is probably the best place to start as you think about custom data and how you might want to make things work. So on the top here, I've got UPS mode, in time span, and battery percent. Those are basically my variables. Okay, the time span one actually has two of them because I'm looking at morning rush and evening rush, but basically, am I in a time span or not? And then the last two that's the output, right? Drive the relay, which then controls the cabinet. Okay, so what we're really going to look for though is this condition here, because the end result we're trying to get to is to have it go to flash only in a certain condition, but not the others, right? If you look at the traffic signal, you can see that only one of them is to flash operation. All the rest, we want to make sure that we're in full ops, okay? All right, so if we go through each of them then, first one here, so UPS is in inverter mode. We're not in the time span. Battery's greater than 40%. So we're not going to be in flash. We don't want to be in flash. We want to be in full operation, right? Because our battery is not below, it's not 40% or below, okay? Next one down. Inverter mode, yep. In time span, no. Battery is 40% or less. Oh, okay. So let's energize that relay because it's an extended outage. That's why we're at the 40% or less. So then, yeah, let's take the cabinet to flash. But we're not in a time span here, so that's good. So we can do that, okay? All right, next one. In inverter mode, in time span, yes. Okay, so we're happen to be in morning or evening rush. Battery percentage is greater than 40%. We're not gonna go to flash. So there's two things that break it right there, right? We happen to be in a time span, so we don't want to be in flash. And also the battery is greater than 40%, so it wouldn't be a low battery condition anyway. All right, and then the last one, inverter mode, yep. Time span, yes. Battery happens to be at 40% or less. We're in an extended outage, but we've decided that we don't want flash in the scenario because of the traffic, because we're in that time span, so it stays in full operation. So as you think about custom data, write out a truth table, think these things out before you start programming it. And it just helps you to frame it, frame your variables, frame your equation as you get into it. Okay. All right, so now that we know what we're gonna do, let's do it. Okay, so I've got my FXM-HP all set up and running. We're connected to it with a web browser here. And let's actually get in and create this time of day, low battery, no line scenario, all right? So how we're gonna do it is we're gonna go over here to the controller, and advanced functions is where you wanna go, and then custom data right here, okay? Then it brings up custom data, and we've got some other tables too, but for now, we're just gonna look at this first one here. You can see I've got a couple already set up. We're gonna add another one. So we're gonna click add custom data, step number 1. Okay, so it just kicks up a new one, comes in with a generic name. Obviously no equation or anything set. It's all ready for us to fill in. So we need to click this arrow then to get there. All right. So here's our configuration, all blank and ready for us to fill in. So we're going to change the name because it doesn't have a name now. So let's give it something that we can remember. So I'm going to click the pencil and I'm going to type in time of day, right? And then low battery, no line and abbreviation, hit enter. So now when we look at it on the table, we can know which one it is we're talking about. All right. If you want more details, you can type that into the description. Okay. And you can see this is the place to write the equation, but we're not ready yet because we don't have our variable set. So we've got to go over here to the variable table and we've got to add our variables. Okay, in this case, we're going to add 4 variables. We could probably get by with 3, but I just want to call it each one so you can see the logical steps of each one. All right, so we're going to add a state variable. And since we need 4, I'm just going to click 4 right now. And so we were all set with 4. Okay. Then I'm going to click the arrow to edit the first one. And now we're going to name it. Okay. So the first thing we're going to watch is the low battery, no line. Let's make sure that we have that. So I'm going to type in L, B, and L. Okay, hit enter. All right, so now we've got it named. Now we have to tell it what to watch. So this is the monitor part. What field do I need this to watch to come back with something? So we're going to click that. All right, it's going to bring up this table here, and we're going to scroll down to find the FXM-HP. And then here's all the list of things that we could monitor, and it's all alphabetical. So we're going to scroll down and go to low battery, no line status. Okay, so you may want to go through all of these as you're playing with custom data and look at, hey, what are all my possibilities? Because there's a ton of things in here that you can monitor. So go through the list and see what catches your eye. All right, so I'm going to save that. Next step is really important, and it's really easy to forget because you think, oh yeah, I got my name and I got the field, I'm good to go. Well, not yet, because you have to tell it what to do with that. So we have to go to the true if part. So we're going to edit that. And we can either be true if true or true if false if you want it to work in the inverse. So up to you how you want to work your logic. So we're going to do true if true, keep it simple. All right. And then now it comes in and says, okay, variable value is false. Currently not in a low battery, no line state. So it's already coming back with the result. Okay. So variable 1 is set. We go back up here to navigate back to our custom data. And now we're going to scroll down. And here you can see variable 1 is set. Let's go do variable 2. Okay, so we're going to name that one. Second thing we're going to watch then is inverter. We want to know when it's in inverter mode. Okay, so I'm going to hit inverter. All right, and now we've got to pick the field. Again, we're going to scroll down to the FXM-HP. All right, and this time we're looking for system mode. There we go. Okay. And you can see it's currently in line mode. And now it's true if. So here's the big change. So the other one was true if true, right? Watch this. Now we've got all these different modes of operation. So even more power when you think about it. Oh man, I could monitor if I'm in buck or boost or wherever I want to monitor. You can monitor all those conditions or multiple of those conditions. So we're just monitoring inverter, so singly. So we'll just go that one. Okay. And so we're saying this is true if I happen to be in inverter mode. Okay, so and we can see the value is now false because we're in line mode. We're not in inverter mode. Okay, all right, so we got some more variables to set. So let's go back. That's 2 done. Let's go to number 3. All right, third one we're going to set, and these last 2 are our rush hour periods. So I'm going to call this one morning rush. Notice how I typed that. This is important. There's no space in my name. Okay, you don't want to use any spaces for naming your variables. It will cause you trouble. It won't work right. So you can use underscore if you want. Typical programming thing is to just use capital letters at the beginning of each word and just put them right next to each other. So I'm calling this morning rush. Your other names you can have spaces on, but not for a variable. So don't allow that. Okay. And then which field are we going to monitor? So now this is different. This is a time span. It's not like AC input voltage or a mode of the UPS. This is a part of the controller, so it's not part of the FXM. And so it's a time span that we have set up where you can set up. So I'm going to first get these variables set up, and then I'll show you how to do it. But I've already got these preset. So you can see here morning rush, okay? And then I'm gonna say within time span, click save, and true if, true, easy to forget to do that. I've done that before and go, oh yeah, that's not working. Gotta get that value in there. All right, so that one's good. Okay, let's go back, set the last variable. Here we go, let's name it. And let's call this one evening rush. Probably already noticed it's been typed in before. So there we go. Now we got to grab that field. That's here too. Within time span, save it, and true if true. There we go. Okay, so now we've got all 4 of our variables set. But I want to show you the time span thing. So we're going to just jump off a half a second or two because I think it's important. I mean, if you're going to be setting these up, you need to know how to do time spans, right? So a couple ways you can do it. You can either search, create time, or you can go into the controller, advanced functions, and do scheduler. So search, create time, or advanced functions, and then scheduler, okay? When you get to the scheduler page, you've got a couple different things you can do. You can schedule an action. That's another feature that's really cool. We won't go into that today. Check that out when you got time. Scheduled time spans is here we are. And you can see I've got a bunch of them. So when the FXM-HP ships to you by default, it's going to have time span 1 and time span 2 preset. And they're basically evening rush and morning rush. You can tweak the times if you want to, or you can make brand new ones. You can see I've got a bunch of different time spans set up. You can see my evening rush and morning rush are here. I've got them set for weekdays, 4 to 7 p.m. and 6 to 9. You know, create them however you want. You can also use this wizard then. So this is how I want to create it. So if I want to add one, click this. Now come in, give it your name, and then choose how you want it to run. You want all days, weekdays, or weekends. Okay, and then what's your start and end time? Click next, and it's going to take you through and make sure that you've got it set the way you want, and then you're good to go. Now you've got a time span, okay? Or you can edit the ones that are there, change the name, and change the times that are in the window. So anyway, very quickly, that's how you do the time spans. How do you get there? Controller, advanced functions, scheduler, or create time. Boy, I wish it would really create time. That'd be a nice feature. But anyway. All right, so let's get back to the data log. All right, our custom data, here we go. Okay, so now we've got 3 of them here. We've got to finish off our equation. We're not done yet. We've got our variables in, so let's go in and get that going. All right, so here we are, and equation. I'm gonna edit that. Okay, so now we start typing. Okay, so remember we're gonna do parentheses, but I'm going to cheat, make it a little quicker for you, save you the typing. I've already typed that in. So it looks like that. So just like I had it in the other example, all typed in, ready to go. I've got my parentheses, I've got my operators, my equals and my ands all set to go. I've got my variables named properly, right? And then I hit save. And watch the custom data status, comes back and says valid. All right, but what if I did that wrong? What does it look like? So let's do that. So I'm going to remove that last parenthesis, hit save, and watch what happens. Error, 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 alarm bells going off, lights are flashing, unexpected symbol, and it tells me where, position 66. So if I counted out the text, it would end up right here, okay? And then it says expected token, it's expecting a parenthesis. So I mean, it already told me what I need to do. So that's kind of helpful. It may not always do that, but in this case, it has. Well, be careful when you're typing too, because when you come back to it, it may highlight the whole thing, and then you start typing on it, and then you've just, you know, deleted what you did. So be aware of the blue selection. All right, so we click save, and now we've got that set. Okay, formula is valid. Result is currently false because this formula is not being fully answered, so it comes back with the false. Okay, so that's the custom data, but what are we going to do with it? We got to do something with it, right? So let's get back to here where we can then drive this to an output. Okay, so let's scroll down. So it's nice that it's all on the same page. So you want to go to change relay right here. So add change relay action. Okay, so it comes up with the generic one again. hit the arrow. All right. And then we've got to go into configuration. This is status, but we got to get into configuration because there is no status yet. So let's name this. All right. So we're going to call it same thing, TOD and LB&L right there. Click save. But now we've got to tell it what relay then that we want it to control. And so we go here and we want it to go to output relay 3. And there we go. All right. And we are set. Okay. So now we've got that all set and we're all ready to go. All right. So that's how you tie that in to your relay. So now we've got one condition done. Let's go back and look at another one. Okay. Okay, so this next one is time of day flash or low battery, no line. So let's say, for example, you want your intersection to go flash in the middle of the night if you have an outage, just immediately to flash, no full ops. I've had quite a few customers request this over the years. Yeah, you know, for after 10 o'clock and before, 6, just go to flash first. Maybe you've got extended outages and you want to make sure that you've got runtime out there for whatever reason. Obviously to keep signals running. So how do you do that? Well, you can do it with a custom data equation. Legacy product can't do it, but you can do it with this. And so, but the other condition is low battery, no line. What if, not during the middle of the night, if it's during the middle of the day and you happen to have a long outage, you may still want it to go to flash when you hit that 40% or lower level. So we're going to bring both of those in, and this time we're going to use some and or statements to make this all happen. So let's take a look at the truth table then. Okay. So here we are, much bigger table, but we are monitoring very similar things. So UPS mode, in time span, and battery percent are for sure what we're going to monitor. You could also do something with timer, but we're not in this case. I'm just going to reference it as an option. Most of our users are basing things off of battery percent when they go to flash. Some will do timer too. All right. So the first two right here are all about the time of day part of this, right? So as we look at it, we'll say in inverter mode, are we in the time span? No. So we're not going to go to flash. We're going to be full operation. We don't care about battery and we don't care about timer because we're just looking at the time of day. That's it. Second one, inverter mode. Yep. Time span, yes. So then we are for sure going to flash, right? So we're solving for the condition that's we're going to write the equation about, which will take us into flash because that's the end goal. Because we only want it to go to flash under certain scenarios. Otherwise, it's full operation. But it helps to call out the other things in the timetable, the full ops, so that you can see, yeah, this is how I want it to work as well to make sure that it doesn't happen in that. So you just want to test this stuff out. All right, middle section right there. Okay, that's talking about non-time of day times. What is it going to do when we're not in that window in the middle of the night? Okay, so we're going to see here inverter mode. Yep. In time span, nope, but it doesn't matter because we're not paying attention to that because this is the or side of the equation, low battery, no line here. Battery happens to be at 40% or less. That's a low battery condition, and we have no line. So therefore, go to flash. Okay, so that's true. And like I said, if you wanted to, you could use the timer too. When the timer counts down and hits 0 from whatever time you had it set at, you would also be in flash. Okay. Last section, just showing how you basically don't want it to go to flash. So just proving it out. So if you happen to be in line mode and you happen to have not be in the time span, we're definitely going to be in full ops. But if you happen to be in line mode and you're in the time span, yeah, we still want to be in full ops. We're not going to flash then either. So helps to show the inverse too. I didn't on the previous setup, but this one I thought I'd throw it in. So anyway, so work with your truth table. We're looking for those flash conditions. All right. So let's go back and set this up. Okay, so we're going to go back to custom data. We're going to add another one. Okay. All right, we got to give it a name. So let's call it time of day or LBNL, time of day or low battery, no line. All right, we got our name. Can't do the equation yet. We got to get our variables going. So let's get our variable set. Again, we're going to use state variables. So let's add them. We're going to use 3 this time. Okay. There we go. And let's get going on them. So the first one, let's do LBNL again. So now, even though we set them up for the other custom data, we still have to set them up for this one. So we can't go over and grab the variable off of another one. We have to set up our own for each custom data, even though it's redundant, right? You know, we've already done this. But hey, you're learning. You're seeing me do this multiple times. That helps. All right, so now we're going to go grab the field, FXM-HP, and then we're going to go down here to low battery, no line status, save it. That one's done. All right. Oh, yeah, you caught that, didn't you? I forgot I didn't set my true if true, did I? All right. See, it's easy to do that. True if true. You get going and you're like, yep, you get ahead of yourself. Got to save that. There we go. True if true. Now we're ready to move on. Okay, so now we scroll down, get to the next variable, and you can see because before I didn't have a variable value, that's how I caught it. I was like, oh yeah, silly me. Okay, next one, name. Next I'm going to monitor again is the inverter. Okay, grab the right field. And here we're going to look for system mode again. Okay, and true if, not if true, but true if inverter. Click save. Okay, so 2 variables set. All right, let's go to variable number 3. All right, and this one is going to be different now because we're going to monitor a different time span. So I'm going to call this one TOD, and now I'm going to use underscore just to do something different. And I'm going to call this one flash time span. Okay, so time of day, flash time span. All right, so I'm going to click save. And now I got to go grab that field. All right, and I've got that one here too. But I'm calling it time of day flash. Use a different name, that's fine. And within time span, and true if true. I know you're watching to make sure I grab that. Thank you, appreciate that. All right, so true if true. Okay, so now let's go back and look. All our variables are set. They're reporting in currently at false. So next step, we got to write the equation because I already showed you how to do the time span. All right, so here we go. All right, equation is a little bit different this time because we're doing something different, right? So we're going to start with parenthesis and we're going to go TOD underscore. Oh, look at that, how convenient. I already had it typed in. So time of day underscore flash time span, that's the first variable I'm looking at. If that's true, and I happen to be in inverter mode, so I'm within that window in the middle of the night and my inverter's on, which means I'm in backup, then go drive a relay. Or here's that little or symbol, the vertical line, okay? Or if low battery, no line status happens to be true, then also energize that relay. So either one of these. So in this case, on the left side, I've got 2 things that have to happen in order for that relay to be energized. And then, or just have the low battery, no line be true. Either one is good. So I'm gonna click save. Now we've got our formula set, all right? Okay, and then now we've got to go and add a relay, have that drive a relay. Okay, so go back to custom data. All right, add change relay action. Okay, we're gonna name it TOD flash or low battery, no line. Click save. Okay, relay to change. Notice this. This is on purpose. We don't have a relay we can change. Shoot. So we need to make one available. All right. So we need to go to status and we're going to change the programming on one of our relays, which we're going to be doing. I'll be going in depth on in 2 weeks when we talk about direct contact relays. So we need to get there and we got to change that status of that relay. So a quick way, there's 2 ways to get to status. You can go here, or there's a shortcut right here, which takes me right to system status. And then I can scroll down and get to my relays, and I can see what's going on. So here's all my direct contact relays, what they're currently programmed for. You know what? We're going to change C4. Is that set up for timer? So let's change that one. So I'm going to click here. Take me to the relay. All right. And then here's what drives the relay. But before we do that, let's change the name of this, because we're going to make this relay be something different now. So it's going to be time of day flash or LBNL. All right, because we want to change that so that it makes sense. So we go back to the status list. We know what that relay is doing. Okay, it's not currently doing that yet, but it will be. Okay, then we look at the is driven by section, and we can see it's being driven by the load shedding relay, a timer. So we're going to go change that by clicking here, and I can go in then, and I can see here's timer 1, and right here it says relay, output relay C4. We want to get rid of that. I want to take that away from the timer, and to do that, I click these 3 dashes. That makes it programmed for nothing. So I save that. Okay. So now you can see I'm not driving any relay with the timer. Now we're going to go back to custom data. Okay. And get back to our change relays. Okay. And then we're going to go to relay to change. And look at that. Now the relay is available. And we are set to go. All right. So, and then also too, I forgot to show you this. So we need to make sure, hey, what is it going to trigger on? So we have to find that equation. So in this case, it's time of day or low battery, no line. Result is Boolean. Forgot to do this on the other one. So let's catch that up, right? So it's going to follow that equation. That's the condition. You want to set that, okay? So it's going to follow and do whatever this says, okay? All right, and then let's get back and do the other one. So I neglected to do that. Got to get that condition set. So we got to have this one because it's time of day, low battery, no line. All right, so now we got to find the custom data equation here, right? And it's this one right here. Result is Boolean. Sorry about that. I meant to do that and forgot to do that for you. So now, as we look at those relays, they're going to be driven by that statement. Okay, so there's the condition on each of them. All right, so that's how you do custom data. You know, it's not tough. There are some steps to it. You got to learn the operators. You got to figure out your variables, figure out what it is you want to do. Take a look at your truth table, right? And say, okay, let's lay this out logically. How am I going to make this happen? What do I want it to do? Okay. So anyway, so that's custom data in a nutshell and a little bit of detail. So as you get into it, if you find you have questions, you want some help, please reach out to us. Would be very willing to help you come up with your formulas once you figure out what it is you want to do. So take a stab at it. If you get stuck, reach out to us and we'll be glad to help you. So, all right, so we got a couple more things to do yet before we wrap up. So user alarms. So the FXM-HP has over 60 of them built in, and you can configure them however you want. But you also have the ability to add your own. That's a user alarm. Say, hey, I want to monitor certain things, and if this happens, then create an alarm, which could then generate email, SNMP, and also give you messages on the LCD and on the web page, so you can see that, hey, whatever condition is you happen to be monitoring, it's actually happened. Okay. So there's 2 types. There's threshold and there's digital. Okay, I think they're both very, very powerful. I think most people will probably be using the threshold alarm, but digital works for expanded stuff. So let's talk about each of them. So threshold alarm, it's just that. Think of a value of some kind. It could be a voltage, it could be current, it could be a counter. And you want to watch and see if that value goes above or below whatever you've set it for, okay? And if that happens, then let's create an alarm, all right? So that's a threshold alarm. Digital alarm is monitoring the condition of something, the state of something. So you can monitor timers and counters also, but like modes of operation or custom data equations. This is a great way to do things, to monitor a bunch of different things and say, yeah, if this is true, then create an alarm. So let's do each of those. I'm going to create a threshold alarm and I'm going to create a digital alarm. So let's get back to the web page. All right, so let's go to the threshold alarm. All right. So a couple different ways you can do it. You can search threshold if you want. Up here in the search, that'll take you there, or you can go simply controller, advanced functions, and right above custom data is user alarms. So easy to navigate to. Okay. And then it comes up with this table, and you can either add digital or add threshold. So let's start with the threshold alarm. Comes in with a generic name. So let's go in and set this up. Click the arrow. Now we can go in and name it. So let's set a AC input voltage alarm. All right, let's do that. So let's call this AC input, and let's say greater than 130. Okay, so anytime the voltage goes above 130 volts, we're going to create an alarm. All right, so I think it helps to have the name actually be like what it is you're doing, so it's a lot easier to identify. All right, what is the source? What are we going to monitor to find out if this condition is true? Well, of course, we're going to monitor the FXM, right? So here we go, FXM-HP, AC input voltage. Okay, all right, and then it comes back and shows us the current values at 118.5. If I get out of the way, you can read that. Okay, then this is the alarm, the actual alarm setting. So we haven't set that up. We've created it, but we have to tell it what to watch for. So we have to give it a user-defined parameter. Okay, and so what are we going to do? We're going to say 130 is the number we're going to watch for. Okay, and notice alarm when value is above or below, my choice. So if you want something above or below, this is where you pick it over here. All right, it's already set for above, and we've got it set for 130 volts. I've got it set as a warning level priority, which means it won't generate an email. That's the lowest level of alarm. If I want something that is higher, then I'm going to click edit, and I can go minor, major, or critical. Okay, so if you really want to be notified on it, I would say for sure then let's set that to minor. Otherwise, it's just going to show up on the LCD, okay, or the web page, but you won't get actual notification by email or SNMP. So, but sometimes maybe that's all you want. So just be aware of that. Be sure to set your priority. Okay. Okay. So we can see we've got 118. So let's test this. All right. So I've got a Variac hooked up to my UPS. So I'm going to turn that up, and we're going to go over 130 and watch the alarm section. And we're here, and watch the voltage. All right. So we can see we're at 133 volts. And it's going to take a few seconds here to capture it. Waiting. Maybe I've got my delay set for a minute. That is possible. There's delays that you can have set up in here, so it will ignore alarms for a certain amount of time. So anyway, so I probably have it set for that. Oh no, I'm sorry, I didn't set that in the wrong spot. Operator error, user defined limit is where I want to change. I didn't scroll down far enough. Here we go. Not the parameter, that one doesn't matter. My mistake. Now we've got the alarm. Okay, so user-defined limit, that's what I want, not the parameter. Okay, so set that to 130 volts. And you can also set a hysteresis. That means it has to change a certain amount before it comes out of that state. So right now I've got it set for 0. If I want to set for 5 volts, it's got to go, greater than 135 or less than 125 to shut off the alarm. You can see I got 142 going in, so we're definitely above the 130. Turn that voltage down, and then it's going to clear that alarm once I get below 130. So here we are at 122. Alarm just went inactive and goes away. Okay, so that's a threshold alarm. You can do it for other things like counters. Maybe you want to monitor how many inverter counts you have. It gets over a certain amount, send you an alarm. That's a possibility too. All right, and then let's set the next one. So let's go to digital alarm now. So controller, advanced functions, user alarms. Okay, let's add a digital alarm. Okay. Here we go. Okay, so now this one, let's name this one. The other one we did greater than 130, but let's make this one a little more powerful. Let's go AC input less than 110 or greater than 130. Those happen to be the transfer points for the FXM 1100. So less than 110 means you're in boost, greater than 130 means you're in buck, it means you're not in line mode. And so it means essentially any mode that's not line, we're gonna get an alarm. You may or may not want that, but that's what we're gonna set up for here and give it a try. All right, but again, we have to say, what am I gonna monitor? We're gonna monitor our AC input voltage. Okay. I'm sorry, no, I'm already doing that. I forgot, this one's a formula. So getting ahead of myself. So yeah, so I've already got this custom data equation written, okay, that's set up to do that, because you couldn't monitor an AC input and say, am I above that or less that? I have to actually have a formula. So I've created a custom data equation that does that. That says, if AC input is less than 110 or greater than 130, let me know, true or false. And so we're going to result this in Boolean. Okay, here we go. Now that works. Okay. All right. And then it's currently false. All right. And you can see I've got I'm at warning level, right? And I could drive a relay if I want. And you can see I can't set it for a value. But let's make this prove out. You see the condition went true. And the alarm is now active. And there we go. Okay. So using a custom data then with the equation, I'm monitoring two things. I'm monitoring if the AC voltage is less than or greater than something, and if so, then create the alarm. So anyway, so very powerful. You can set those up however you want. It's up to you. A lot of flexibility there. Okay. All right, hopefully you find those powerful. Okay. So that pretty much concludes this webinar. So this was going over custom data and user alarms. Hopefully you found it helpful. And you can find the details. We now have these up on our website, so you can actually get a hold of these guides. They're in our application notes section. There are also, if you navigate to the FXM-HP, there'll be a link that will take you there, and you can download these guides as well. So anyway. All right, so let's see if we have any questions. Not quite sure how we're going to make this work.
Can you hear me,
here
Mike?
you are. I hear you. Your audio's back.
You have no idea. First of all, apologize. I was having a little bit of a glitch, like right before that. Like not to go into detail, the laptop basically closed down. I accidentally closed it 2 minutes before the webinar. So I was able to see you, but it seems like the audio lost. So I end up using another computer right now. But anyways,
Okay.
thank you. Thank you for continue on and soldier on. I have a couple of people say, we can hear Mike. So I was like, as long as people can hear Mike, I'm fine with it. So I'm just going to give a couple of minutes of people to see if they have any questions. I don't see actually any questions coming in just yet. But to go along with what Mike was saying, we do have the application notes already put it up on alpha.ca. So it's www.alpha.ca. If you go into the support section, you will see one tab called application notes, and you can see all 6 of them actually up there right now already. It was uploaded a couple of days ago, so that's perfect. Yeah, and then otherwise, Mike, yeah, I don't see any questions coming in. Do you have anything else to add? I saw the very interesting table called the truth table, which I always thought that it was interesting. How it's called.
Only be that easy, right? Yeah, right. Here, speak the truth. Yeah, you got to have truth tables. They help you think through the process as well. So I guess a couple of reminders. So I guess for those of you who were there a couple of weeks ago, we talked about formulas for the logs. We've got that written up now. It's just about out of marketing, and I'm guessing we'll be popping that up on the website too. If you were part of that group last time, we'll also be emailing that out. So haven't forgotten about it, just waiting for the paperwork to get done. 2 weeks from today, July, what is that, 17th, we will be doing the next and the last of this webinar series that will be on the dry contact relays. They're not hard, but they are different. As you saw where I had to tell that relay to not be programmed by something else. You can program multiple things to drive a relay, but when you've got something dedicated like a timer, that's a little bit different, in which case you need to take that out. So anyway, so we'll get into all that in a couple more weeks. So, but
That's
thank you.
great.
I mean, anything else pop in, Humphrey?
No, there's a lot of thank you though. There's
Okay.
a lot of thank you, Mike, from people. So I think that people did get the what they want to hear, and I do have one or two questions. They said that they actually will send an email to follow up with you instead of asking you here. So I think we're
Okay.
good. So we're wrapped.
All right, so
And,
I expect everybody to be up all night writing their equations and thinking about this stuff.
and truth tables.
Exactly.
That's it. Well, again, apologize for not being there to open for you earlier, but seems like everything worked out. So so we're good.
All that counts. All right, everybody, make it a great day. Good talking to you again. Talk to you in a couple of weeks. Thanks now.
Thank you. Bye.
Bye-bye.